Okay, so let's look at an example, and this example is using oxidation numbers to deduce if something has been oxidized or reduced. Now, this equation here, it's for a reaction that we carried out in the science lab, and we calculated the enthalpy change of reaction for this reaction here. We had copper sulfate, which is blue solution. We added some zinc, and we made zinc sulfate plus copper. Okay, so we're going to have a look at which species has been oxidized and which has been reduced. Okay, so let's start by deducing the oxidation numbers. Okay, so let's start with the zinc. Now, zinc is a solid, which means it's an element. So elements have an oxidation number of 0. Now we have the copper sulfate. So we are interested in the copper because the sulfate ion is what we call a spectator ion. It doesn't get involved in the reaction at all. So we're interested in the copper. So what's the oxidation number of the copper? Now, the SO42 negative ion has a 2 negative charge. So that means the copper must have a 2 plus charge. Now, the oxidation number is the same as the charge on the ion, but we write it as +2, not 2 plus. Okay, let's go to the zinc. Now, again, it's SO42 negative, so the Zn zinc must be 2 plus as the ion. But for oxidation numbers, we're going to write +2. And then we have copper here, which is a solid, it's an element, so it's going to be 0. So let's have a look. We've got the copper, we've gone from +2 to 0, the oxidation number. And we've got zinc, we've gone from 0 to +2. Okay, so for the copper, the oxidation number has decreased. Okay, and for the zinc, the oxidation number has increased. So from here, we can classify these two as either being reduced or being oxidized. So here it is. Oxidation is an increase in oxidation number. Reduction is a decrease in oxidation number. So now let's look at these two again, the copper and the zinc, and we can decide which one has been oxidized and which one has been reduced. Okay, so we can see that the Cu2 plus has gone from +2 to 0. That's a decrease in oxidation number, so that's reduction. Okay, and the Zn has gone from 0 to +2. Okay, so the zinc has been oxidized, or it's oxidation. So that's how you can use the oxidation numbers to determine if something's been oxidized or reduced. Okay, so these two here are important to know. In addition to the oil rig, oxidation is loss, reduction is gain. Okay, so let's look at some examples here. So this one is calcium plus Sn2 plus gives you Ca2 plus Sn solid. Okay, so we're going to deduce the oxidation states of each one. So let's start with the calcium. It's a solid, it's an element. If you see solid, then you know it's an element, right? So that has an oxidation number of 0. And then the Sn2 plus, the oxidation number is the same as the charge on the ion, but it's written as +2. On the right side, we have calcium Ca2 plus. So again, the oxidation number is the same as the charge on the ion, but it's written as 2 plus. And then the Sn is a solid, so it's an element, so it's 0. Okay, so let's look at the changes. So we have calcium going from 0 to +2, and we have the N2 plus, going from +2 to 0. So this is an increase in oxidation number, and this is a decrease. Okay, so increase in oxidation number is oxidation, and a decrease in oxidation number is reduction. So the calcium has been oxidized, the SN2 plus has been reduced. Let's look at one more example. Now this is slightly more complicated because now we have three things. We have the nitrogen, the hydrogen, and the oxygen, the O. Okay, so it's no different to the one before. You just have to deduce the oxidation numbers first. So let's start with what we know. We know that hydrogen is +1. Okay, so if there's three of them, to make this a neutral compound, the N must be -3. Now here O2 is a gas. If you see O2 as a gas, it's an element, so it's 0. Let's go to the right side. O as part of a compound is -2, so the N must be +2 because there's no charge on NO. And here we have oxygen as part of a compound, it's -2, and hydrogen is usually +1. So there we go. So let's look which ones have changed. So why don't we look at hydrogen first? +1, +1. Well, there's no change in the hydrogen, so it hasn't been oxidized, it hasn't been reduced. What about the N? It's gone from -3 to +2. That's an increase in oxidation number, so that has been oxidized. Okay, it's oxidation. And then we have the O. It's gone from 0, sorry, not -0. There's no such thing as -0, is there? Let me just erase that. It's gone from 0 to -2. That's a decrease in oxidation number, so it's reduction. Okay, so that's how you use oxidation numbers to determine if something's been oxidized or reduced. Concentration of H+, the pH will decrease. Okay, so basically we can say